Welcome back. You have started Part 2 of the online Field Technician training for the Asphalt Field Technician 1 and 2. This training is produced by the Materials and Research Division at the Nebraska Department of Transportation. If you have not completed Part 1 of this training, return to the NDOT website and complete it first. This online training is taken at your own pace. Please take notes during this presentation as you will be tested for certification. A pretest will need to be completed before taking the official testing. Note, this is a requirement. You can complete the pretest while watching this presentation. I first want to welcome you. My name is Amanda Schinkel, and I will be narrating this training. If you have any questions, please contact the Materials and Research section at 402-479-4697. Thank you for completing Part 1 of the online Field Technician training. In Part 2 of this training, you will learn about sampling binder and emulsion, roadway sampling, hot mix and density cores, plant and laydown records, QC, lab equipment testing, and finally, a section on troubleshooting and miscellaneous topics. We will begin with Module 4, Sampling Binder and Emulsion. This includes discussion on asphalt binder types, blending, emulsions, labeling, and sample custody. This section will have its own certification for binder and emulsions, so pay specific attention to these details. Both binder and emulsion materials require sampling to be performed by the contractor's personnel that are certified. This is noted in the Material Sampling Guide and Standard Specifications. NDOT personnel needs to only observe the sampling. The contractor will physically obtain the material. The sample on the left is for binders. This is a metal 2-quart container. The sample on the right is for emulsions. This is a plastic 1-quart container. Please note that the sample information is written directly on each sample container. Performance-graded binder is the cement that holds the mix together. Collect one 2-quart can sample for each 200 tons of PG binder. The sampling frequency must be for each grade and source of PG binder. A minimum of 1 sample per project will be required. Samples of PG binder are to be submitted within 10 days to the Bituminous Rheology Lab. Binder sampling is only to be performed by contractor-certified sampler. The contractor shall perform sampling with a NDOT inspector present. Ensure proper safety equipment is worn for contractor sampling, a face shield and heavy heat-resistant gloves. PG binder is typically stored at 300 to 350 degrees Fahrenheit, so if taking immediate possession, wear the proper gloves. This note is very important. Ensure that 1 gallon is poured to waste through the sample valve before each sample is taken. Make sure to provide an adequate number of sample cans to the contractor and ensure that they are stored with protection from the elements and kept clean. Only dry rags can be used for cleaning off cans and bottles. Do not use a solvent or oil-based product for cleaning. This can contaminate the sample. The sample must be obtained at the plant. The sample needs to be taken from the line between the storage tank and the mixer, or from the tank itself that is supplying the material. Next, you will see a video on sampling binder. Note that the certified technician begins to pour a gallon to waste in the green bucket, then obtains the actual sample in a steel 2-quart metal container. Now I will go over some of the naming conventions on PG binders. PG stands for performance grade. The first number shows the pavement maximum average temperature rating for 7 days. The letter that follows stands for the type of traffic loading the binder is used for. In this case, it is V for very heavy. The last number shows the 1-day minimum pavement temperature the material is rated for. In this example, it is negative 34 degrees Celsius. The traffic loading designations are as follows: S for standard traffic loading, H for heavy traffic loading, V for very heavy traffic loading, E for extreme traffic loading. So what happens when the contractor has to switch binders during the project and only has one tank? This is called PG binder blending. There are 2 types. The first one is when they blend 2 different suppliers, and the second is when they blend 2 different grades. PG binder supplier blending is allowable if NDOT is notified and the blend is approved, and the contractor supplier has ensured compatibility. Please note on your sample if the PG binder is blended. The contractor should use up as much of the existing material as they can before switching over. If a sample is to occur with a blend, obtain the sample and identify it is a blend. Bituminous rheology lab must be notified when it is a blend so that the lab can test it under the proper testing temperatures and parameters. Now let's take a look at emulsion sampling. Emulsions are typically oil blended with water through the use of emulsifiers, or soap. 1 sample is required per project for each type of emulsion. You can obtain the sample at any time during the project. However, earlier is better. If we need more samples, you will be contacted directly by the laboratory. Once the sample is collected, it must be shipped within 5 days to the bituminous rheology lab. This will be performed by the contractor with inspector present. Proper safety equipment must be used for the contractor sampling: a face shield and heavy heat-resistant gloves. Emulsion is typically stored at 160 degrees Fahrenheit, so if taking immediate possession, wear the proper gloves. Again, ensure that 1 gallon is poured to waste through the sample valve before each sample is taken. Use clean, quart-size, wide-mouth plastic bottles with screw-top lids. A sample is a single 1-quart bottle. Take at the middle third of the loaded transport. Only use dry rags for cleaning off cans and bottles. Do not use a solvent or oil-based product for cleaning. Next, you will see a video on sampling emulsion. When sampling, ensure that the contractor fills the plastic bottle fully and squeezes until the emulsion is about to overflow, before placing the lid. This gets most of the air out of the sample. Excess air inside the bottle can cause a film to be formed on the emulsion surface. Now let's look at the sampling video.
Filling the waste, 1 gallon waste. Now we're going to fill the container, which has the number on the side. This is sampling emulsified.
Here is a reminder. Each sample needs the following to be entered into AWP or Site Manager and on the ID tag: project number and contract number, project manager, bill of lading number for emulsions, lot number for binders, sampling date, supplier or manufacturer, grade of material, person sending the sample, and person that took the sample. Also an important reminder, emulsions must reach the lab within 5 days of sampling. Binders must reach the lab within 10 days of sampling. This is a good example of a sample ID where all the relevant information is filled out, including the lot number that the material is being used in. Here is some information on how to ship binder and emulsion samples. Sample containers are available at NDOT's purchasing and supply, along with boxes for shipping. If you are a consultant, contact your state representative for containers to ship. NDOT uses UPS Campus Ship to send the samples. Remember, the material must make the 5-day limit for receiving the emulsion samples to the bituminous rheology lab, and the 10-day limit for the PG binders. One final reminder, this section on binder and emulsion sampling will have a separate test certification over these materials. Okay, now let's move on to the next module. Module 5, where we will be covering roadway sampling, hot mix sampling, and density core sampling. Here you will learn more about the random sampling schedule, verification testing, testing tolerances, production sampling, HMA sampling, roadway and windrow sampling, sample splitting, sample identification, cold feed sampling, density cores, longitudinal joint cores, and sample custody and storage of samples. Let's start with looking at the 2 core principles for acceptance of materials. First, we will look at the various sampling methods, and then we will look at the verification testing. There are many sampling methods to accurately evaluate a population of data. The good news is that NDOT uses what is called a simple random sampling. In other words, we draw random numbers to select which sample to test. So let's look at the second core principle. It is verification testing. Here, the QC testing is performed by the contractor, and the QA testing is performed by NDOT. Each sample is split into 2 equal samples, 1/2 for the contractor and 1/2 for NDOT. The contractor sample is what is called the quality control test. The NDOT sample is called the quality assurance test, and it is quite that simple. If the NDOT test correlates with the contractor's test, we say that the test results are valid, and we accept the contractor's test to be used to determine acceptance and pay factors. So now, more specifically, let's look at how we select the sample to perform the QA/QC verification testing for hot mix asphalt. Asphalt acceptance is based on a 5,000-ton lot. Within this 5,000-ton lot, it is separated into 1,000-ton sublots, 5 of them. As you can see, the first small box is Lot 1, Sublot 1, and the second small box is Lot 1, Sublot 2, and so on until we get to Lot 1-5. Each of these 5 sublot samples are obtained randomly from what is called the Random Sampling Schedule, or the RSS. We will look at it in more detail in a little bit. Each of the sublot samples, 1-1 through 1-5, are then split into 2 identical samples, one for the contractor and one for the NDOT. The NDOT keeps all 5 of their samples in secured custody. Then one of those samples are selected randomly from the random sampling schedule. Let's say sample 1-2. Now the NDOT split sample 1-2 is submitted to the NDOT lab for verification testing. If the NDOT QA test results correlate with the contractor QC results, then the entire 5,000-ton lot QC test results are accepted, and their results will be used for calculating pay factors for the entire 5,000-ton lot, and the remainder of the split samples can be discarded. If either the air voids or FAA results do not correlate with the NDOT lab results, we will reject the contractor's QC testing for that lot, and they must use the NDOT's results. This will also initiate a full review of the contractor's testing and equipment, what is called an independent assurance, or IA review, by the quality assurance team. The rest of the split sample must be submitted to the NDOT Quality Assurance Laboratory for further testing. Yes, we have a problem here. We will discuss more actions that take place when testing is not correlating between the NDOT and the contractor. Before we go into that detail, I want to discuss the RSS. So now let's take a look at the random sampling schedule that is generated for asphalt quality assurance and quality control sampling and testing. Each project has its own specific random sampling schedule. The random sampling schedule is computer generated and is available on OnBase. If you have not received or you have lost the random sampling schedule for your project, please contact your quality assurance manager. This is a top secret and confidential document that is only to be shared with NDOT staff. If you believe that it has been compromised and seen by the contractor's staff, you must get a new RSS generated. Our entire acceptance program for hot mix asphalt depends on this security. Now let's take a few minutes to familiarize ourselves with the random sampling schedule. Here is the random sampling schedule. An RSS is generated for each type of mix on your project. It is randomly generated and includes columns for each paving width that you should have on the project. First, you want to confirm that the random sampling schedule is for your project that you are working on. Across the header, you will find project number, control number, name of road, project material used, and asphalt type. Here I have expanded the top row of columns. The lot column shows the lot that you are on, which represents 5,000 tons each. The sublots each represent 1,000 tons. The ton to be sampled columns are to represent the truckload in which the sample is to be taken from. There are ways to keep track of your tonnage, either by the lot or by the project running total. We will discuss this further in later slides. The distance from edge and the distance to core columns are used to determine where the densities will be taken. Distance from the edge is measured from the outside edge of the lane being paved. Use the appropriate distance of edge column based on the width of the paving. The distance to core is the distance ahead or plus and back or minus station from the original sample station where the density will be taken. The recuts distance to core column indicates the distance ahead or back stationing from where the original hot mix sample was taken. The joint density column indicates the in or inside and out or outside joint where the joint density is going to be taken for the lot. Inside is toward the center line and outside is toward the shoulder. If the contractor chooses to use the gauge for joint densities, they shall cut a correlation core in Lot 1 and at a minimum of every 3 lots after that. The FAA-CAA cold feed column indicates the sublot in which the contractor is required to get the cold feed sample for the FAA and CAA testing. This also indicates the sublot in which the asphalt and cold feed samples will be delivered to the NDOT laboratory for verification testing. The field density column indicates the core that will be cut and delivered to the appropriate lab for testing. However, if the contractor chooses to use the gauge for density testing, all of the cut cores will be delivered to the NDOT laboratories. Please note, these are correlation cores, where one core is obtained every 15 sublots. The TSR column indicates the sublot in which the contractor will prepare and submit the tensile strength ratio specimens to the Lincoln Central Laboratory. So now let's put this RSS and the sampling together. Here is the project RSS. We will use sublot 1-2 in this example to demonstrate how the QA/QC process works, with the contractor performing the QC testing and the NDOT performing the QA verification testing. According to the random sampling schedule, lot 1-2 is the sample that the state would test. It also shows a cold feed FAA would be taken. The cold feed would be split in half and sent along with the hot mix asphalt sample. Although the specifications do not say to take a cold feed FAA on every sublot, it would be to the contractor's advantage to take one and split it with NDOT just in case a dispute arises and a referee testing would become necessary. Please note, for the cold feed FAA, the contractor must add the wrap aggregate after burning off the binder. Now let's take a close-up sample of 1-2. The contractor will collect a 75-pound sample and split it in half to get two representative halves, one for the contractor and one for NDOT inspector. The NDOT inspection team shall be present and collect the NDOT half immediately after splitting and deliver it to the appropriate NDOT lab. The contractor will test their half and put the results on their SuperPave software. The NDOT lab will test their half. The contractor's results and the NDOT's results are put into the NDOT lab test report sheet, and the results are reviewed to see that they meet allowable testing tolerances for all tests performed. The production tolerances and correlation tolerances will be reviewed for acceptance. Here is a list of the properties the sample is tested for: air voids, fine aggregate angularity, or FAA, asphalt content by ignition oven, gyratory density, or GMB, maximum specific gravity, or GMM, coarse aggregate angularity, or CAA, field core density, and gradations. The air voids and FAA are used for acceptance of the contractor's QC testing. The other properties are used for correlation only and would only initiate a review of the tester and equipment when out of testing tolerances. So what exactly happens if the two materials don't test the same? Well, this is considered out of tolerance material. As stated in the previous slide, if the air voids or the fine aggregate angularity do not correlate, this will result in rejection of the contractor's QC test results, and the NDOT results would be used to calculate pay factors. In the case of the other properties, they would trigger an IA review only. Again, we accept our contractor's quality control process for each lot based on air voids and FAA. Here is the exact language from the SuperPave specification section 1028.03.6b. Paragraph B. The result of the contractor QC testing will be verified by the department's verification tests. Any sample outside of the tolerances in Table 1028.15 and 1028.16 will result in an independent assurance or IA review of testing and may result in the department test results being applied. Subparagraph 1. On any given lot, if the results of the air void verification testing and its companion QC testing are within 1% air voids, the air void verification for the entire lot is complete, and the contractor test results will be used to determine the pay factors. If the air void verification test results and the companion QC test results are outside the above tolerances, the results for the verification testing will be used to determine the pay factor for that sublot. Any and all the remaining 4 department sublot samples may be tested, and the department sublot test results may be applied to the respective sublots, and the resulting pay factors will apply. Subparagraph 2. On any given lot, if the results of the FAA verification testing and its companion QC testing are within 0.7%, the FAA verification for the entire lot is complete, and the contractor test results will be used to determine the pay factor. If the FAA verification test results and the companion QC test results are outside of the above tolerance, the results from the verification test will be used to determine the pay factor for that sublot. Any or all remaining 4 department sublot samples may be tested, and the department sublot test results may be applied for the respective sublots, and the resulting pay factors will apply. If any of the other properties tested do not correlate, there will be an IA review conducted. Certain corrective actions will need to be made by the contractor to rectify the discrepancies through the review and core analysis of the testing and equipment. Generally, the QC program is still accepted when this is resolved. The NDOT Quality Assurance team will keep you advised of the steps you need to take and the outcome of the IA review and additional testing results. There are 4 samples we obtain for asphalt. First, the cold feed or aggregate sample, and next we will have the liquid binder sample. We will then need to collect the blend of aggregate and binder that makes the hot mix asphalt sample. And finally, the compacted asphalt, or better known as the roadway density core. Now let's go back to the random sampling schedule sheet. Here you can see the X marked in the cold feed sample column. This will determine when a cold feed sample will need to be obtained for the project. This will be obtained in accordance with the running total of tonnage, and to be done at approximately the same time the hot mix asphalt sample is obtained. If you need help understanding the RSS, please contact your project manager or quality assurance manager. Here is how you need to sample individual aggregate stockpiles. It is the standard practice for the sampling aggregates according to the AASHTO T2 and the ASTM D75. Key reminders: sample in at least 3 equal increments, combine the 3 equal increments to form 1 sample, then split the sample to the required size for sieving. Now we are going to cover the cold feed sampling. This sampling is at the plant and only done by the contractor. The first method is conveyor belt sampling. They must stop the plant in order to obtain the sample. A template is used to block out a section of material on the conveyor belt. Then the material is scooped out. All material within the template needs to be removed. The fine material will be swept out with a brush and collected. This will need to be repeated to get 3 increment samples. The next method is the stream flow method with a diverter chute. The chute gets diverted and a small sample goes down the slide area. They will still need 3 increments for the combined sample. Next you will see a video showing different types of methods. Again, this is to be taken by the contractor while the NDOT personnel is observing. Notice there are 3 incremental swipes for the samples.
The first method of collecting a cold feed sample shown is by stream flow. A contractor passes a container through a diverted aggregate stream. Multiple passes are collected until a large enough sample is obtained. The next method shown is from a diverter chute. A mechanical arm sweeps across the belt and sends material into the chute to be collected at the bottom. The final way shown, a bucket collects the stream and is sent to the chute, to be collected at the bottom.
We've already discussed the types of mixes, but here is a reminder on sampling. The types of hot mix asphalt that we use are SPR, SPH, SPS, LC, SLX, and SRM. One sample is obtained for each 1,000-ton sublot and is tested by the contractor's lab. One split sample representing one sublot is tested by the NDOT lab. Again, this is indicated by the random sampling schedule. Let's talk about the hot mix sampling and control. Sampling and testing are the most important functions in measuring the hot mix asphalt quality. You must be able to verify that the contractor is taking representative samples, observe the sampling and delivering of the split sample by the contractor, get the NDOT samples to the proper testing facility. This is important because time is essential. If test results are not favorable, adjustments to the mix or conditions need to be addressed. Data derived from sampling and testing determines whether the final product meets specifications. The most important consideration in sampling is to be certain that the sample taken is a representative of the sublot. Now let's go over an example to calculate where the sample is going to occur based on the day's production. Yesterday's production ended where the red line is, and let's say that was 3,931 tons. The next sample that needs to be obtained will be for lot 1-5, and tonnage will be at 4,600. So we will need to subtract 4,600 minus 3,931, which equals 669 tons. That will be the tonnage when sample 1-5 is taken during today's production. But how will you know how much tonnage has been delivered to the job site? Well, as a laydown inspector, you will receive tickets that will look similar to this. Every truck delivered to the job site has a ticket that should be obtained and kept for record keeping. On these, you are looking for general information, such as date and time, ticket number and truck number, and tons delivered. Note that not all plants have a combined tonnage quantities. If this is the case, you will need to do simple addition every ticket to obtain a cumulative total for running tonnage. Now let's get to the sample. HMA samples can be taken from either the windrow or behind the paver. It is important to know that you are sampling the correct location according to the RSS. In the specifications or special provisions, approximately 75 pounds of material should be obtained and then split with a splitter or quartered. If the sample is taken to the contractor's lab for splitting, a hot box is necessary for transporting. Often contractors will split on the roadway. At this time, the NDOT inspector should take the split sample at the roadway. If the sample is split in the lab, take control of the NDOT sample immediately. This cannot be stressed enough. When taking split samples, make sure that the contractor's sample is not from one area and NDOT's from another. They need to be the same material from the same location, and then take immediate custody of your split. The equipment needed for sampling hot mix asphalt is as follows: a square-nosed shovel, sample containers, hot box or insulated container for transferring samples, a large pan for quartering or a sample splitter, and safety equipment such as gloves. Let's look at how to sample from a windrow. The contractor will dig into the windrow about 1/3 of the way from the bottom until enough material is obtained to fill the container. Always sample from the middle 2/3 of the windrow and not from the ends. Select one or more areas within the middle of the windrow. Trench across with a flat blade or shovel, filling your sample container as you dig. This is an image of the contractor personnel taking a hot asphalt sample from the windrow with a square nose shovel and placing the sample into 2 pails. Next, you will see a video on how windrow sampling is done. Note that the material will need to be appropriately split in the lab after being obtained in the field, unless using a sample splitter on the job site. This image shows the 2 splits of random samples that have been taken from the windrow. These must be split while the material is still hot. HMA sampling from behind the paver. Again, as an inspector, you should be making sure that the sample location is correct according to the NDOT random sampling schedule. The area that is to be sampled should be marked with a template or shovel. Ensure the area is large enough to obtain the correct amount of sample for both the contractor and the NDOT lab, approximately 75 pounds. All the material for the marked area should be obtained. The picture on the left is of a hot box or insulated cooler with 2 buckets that will be kept inside the cooler until able to split. It is important to keep the sample hot. The picture on the right is of a quarter splitter. It provides a 4-way split with buckets to catch the material. 2 buckets are taken from opposing corners, which will represent 1 sample. These 4 buckets will produce 2 samples, one for the contractor and one for NDOT. Here are more views of the mechanical quarter splitter and how it is used. Notice the 4-way split and the buckets used to catch the asphalt. After the sample is split, the buckets on opposing sides are combined to make 2 samples. Here is how to split a sample by the pan quartering method. First, dump the entire sample into a large pan. Then spread the material out evenly in the pan. Cut the sample into quarters. Then take opposite quarters for each sample. Next, we will discuss providing all the proper identification information for the sample. Proper labeling of split samples must include project number, date, lot and sublot number, type of mix, the station number, which lift the sample was obtained from, which lane the sample was obtained from, and the JMF number or job mix formula. When delivering a sample to the NDOT lab, please make arrangements for the contractor to send their correlation testing results. Since it's so important, I want to reiterate some of the points about sample storage. The hot mix asphalt sample from the random sampling schedule is the sample that will be delivered to the NDOT lab. This should be done as soon as practical. The contractor's results shall accompany the sample to the NDOT lab. NDOT split samples not delivered to the NDOT lab shall be stored in a clean, dry, and secure location. The storage of these samples should not be at the contractor's lab. This is an image of a sample bag containing a random sample for the NDOT lab. Note that this sample has all the required identification labeled on it: project number, JMF number, type of mix, lot number, date sample was obtained, tonnage, station sample was taken at, job name with the control number, and the lane the sample was obtained from. Now let's take a look at roadway density samples. Density samples are taken for determining density for each 1,000-ton sublot, at locations specified on the random sampling schedule. For every 5,000 tons of asphalt, there will be 5 cores, 1 for each sublot. The average of these 5 density samples will determine the acceptance and pay factors for the lot. For density testing, the contractor will determine the test method in the pre-construction meeting, either by cutting cores or using a density gauge. If using the density gauge, the cores must still be cut and tested for Lot 1 to establish correlation. Density testing will be performed by the contractor under direct observation by the NDOT project personnel. Some things to note about density samples. When the nominal layer thickness is 1 inch or less, density samples do not need to be taken. When the average thickness of the 5 cores in a lot is 1 inch or less, the testing of the density for this lot will be waived. If the nominal and average thickness are both more than 1 inch, but some of the cores are less than 1 inch, more cores shall be cut at random locations so that all 5 cores for the lot are 1 inch or thicker. If at the completion of the project the final lot consists of less than 5,000 tons, a minimum of 3 density tests shall be taken. So what cores go to the NDOT lab for correlation testing, you might ask? Well, we need to go to the random sampling schedule again. The RSS will designate a correlation density core in the field density column. According to this sheet, it will be sample 1-2 and sample 2-4. These density cores will need to be sent to the NDOT lab for verification testing. When obtaining the density samples, the random sample schedule will give you all the information that you need. Let's say that lot 2-4 hot mix asphalt sample is at station 480 plus 50. The information shows that the density sample will be taken 12 feet from the edge and plus 77 feet ahead. So add 77 feet to station 480 plus 50, and you will get station 481 plus 27, and it will be taken 12 feet from the edge. Now we need to cover one additional required density. It is called the longitudinal joint, and one is taken for every 5,000 ton lot. The RSS will designate which sublot the longitudinal joint density core needs to be taken from, as well as which edge of the mat it is to be sampled. Out means it is taken from the outside edge or 0-foot offset. In means it needs to be taken from the inside edge or 12-foot offset on a 12-foot roadway. This shows the joint density will be taken in lot 1-1 on the inside edge at the center line, as I have shown in the next slide. So from the previous density layout, we need to take one more core for the longitudinal joint density. This will be in sublot 1-1, shown in the green. It will be taken 1 inch from the joint on the inside. This is separate from the average 5 density samples. Since the longitudinal joint density core is separate from the other 5 density samples in the lot, it requires a different pay factor as shown in this table. This pay factor table is also in your contract and is automatically calculated into the software. Okay, now let's look at how we need to get the roadway density cores. This picture is showing the contractor cutting a density core. The inspector is responsible to mark the location. When you mark the density location, make some distinct paint marks on the road and tell the contractor to cut the paint so that you can positively identify the core. In fact, taking a picture and keeping it in your phone for custody identification is a good practice. This is how it will look once the core is taken from the road. The hole that was created will need to be filled with material by the contractor. This is an example of an asphalt core that has been cut and labeled with a paint pen. The contractor will test this after allowing it to dry from being cut. The inspector will then bring it back to the appropriate NDOT personnel so it can be tested for correlation at the NDOT laboratory. The density cores need to be labeled with the following information: the type of mix, the JMF number, and the lot number. If we read this core, it says that this sample is an SPH mix with a JMF number of 513, and it was taken from lot 2-1. Let's discuss how a density correlation is conducted between a core and a density gauge. This is the location of the density test. It was figured from the RSS. As you can see, this location is clearly marked and labeled for lot 1-1. This slide shows the density gauge on the left and the reading locations on the right. This density gauge is called the PQI, which stands for Pavement Quality Indicator. You will notice that there are 5 readings taken at each density location. This layout is shown in the contract specifications for reference. Here is a visual of the gauge pattern to determine density. Notice its position on the painted circle core location. The center photo is on the painted core location. Now notice the photos in the other 4 quadrants. The gauge is being moved over the core's offset, as shown in the previous diagram. For longitudinal joint density and correlation, when using the density gauge, use this pattern. Make sure to use the density gauge 1 inch from the mat edge, as detailed in the provisions by the random sampling schedule. Now let's look at the density reporting form. This page is completed by the contractor and is embedded into the contractor SuperPave software. Note that this page has the project number, location, type of work, control number, mix type, and JMF number all at the top of this page. If the contractor has low densities and pay factors, a set of new core recuts can be requested by the contractor. This is an all-in decision. The contractor must recut all the 5 mainline cores, and this will be the final density measurement pay factor for the lot. This will be allowed in lots with a density pay factor of less than 1. These recut density cores are to be taken no later than the working day following the completion of the lot. No re-rolling is allowed. The average density of the recut cores shall be used to establish the density pay factor for the full lot. So where do we recut the cores? There is one column on the RSS for recuts. Just go to the recuts column. For this example, let's look at the sample 2-4 again, which shows plus 13 feet for the recuts on this sample. The original HMA sample was taken at 480 plus 50. The original core was taken at station 481 plus 27 at 12 feet from the edge. The new recut for 2-4 is 480 plus 50 plus 13 feet, which equals sampling at station 480 plus 63. The offset for the recut will remain the same as what is established in the RSS. This example is 12 foot from the edge. When cutting cores, NDOT personnel will observe the contractor cutting the core. NDOT personnel will then take immediate custody of the cores upon completion of testing. The cores shall be positively identified. When the contractor chooses to determine the density with a density gauge, the voidless number, determined from the RICE test, must be used for each test. Readings shall be verified by NDOT personnel, and verification tests shall be taken by correlation core samples every 3 lots, 15 density tests. As we move into Module 6, we will discuss plant and laydown records, QC testing, and lab equipment testing. This will include an overview of asphalt plant records, asphalt laydown records, QC testing, and SuperPave software. Well, I know this looks like a busy sheet, but it is very vital to the project. The next 18 slides contain several busy project tracking spreadsheets. I want to cover them to just get you familiar. You will learn more on entering data in the sheets when you are actually using them on the projects. Here is the first one, the asphalt plant book. This helps inspectors keep track of how much material was used, where it was placed, and if there was any waste. Inspectors should go through this with their contractor daily to make sure that everyone agrees on the quantity. Daily agreement on quantities will save you a lot of time and avoid arguments on quantities at the end of the project. This is what the plant book printout looks like for the summary of the daily plant records. This is a tank volume chart. Each plant's binder storage tank shall have this. It is provided by the tank manufacturer and made available by the contractor. It is necessary for keeping track of the daily binder tonnage. This is a copy of a shipping ticket for PG binder from the transport. It has the product PG58E-34, the temperature, specific gravity, and the amount of product delivered in gallons and tons. Here is an NDOT form for transfer of asphaltic material. This is filled out at the end of each project when the materials are going directly to another NDOT project. This helps the next project staff begin their accounting records for their asphalt plant book with the asphalt binder inventory. This is a copy of the laydown record sheet. It is used for keeping track of the tack coat that is used through the project. Entries are pretty self-explanatory. They are done by date, beginning and ending of stationing, the width of the lane and gallons used, and it will compute the shot rates. Keep in mind that different coverage may be required depending on what kind of surfaces you are laying on. For example, if you're tacking an existing roadway, milled surface, or between each lift. This is the asphalt laydown record. This provides tonnage data and locations that help ensure the contractor is laying the correct tonnage per station and not overrunning or underrunning on material. It is completed by entering the starting and stopping stations, lane width, depth required, actual depth placed, and accumulated delivered tons according to the collected truck tickets. It automatically calculates the rates for you. Before moving forward, you will see a presentation on calculating tonnage rates in more detail from the NDOT Tech Talk video series. First, let's define what a tonnage rate is. It is the amount of tons of asphalt required to pave one station of the roadway to the specified width and thickness that you are paving. For those of you who do not know, when we refer to one station, a station is 100 feet of distance, and it is referred to as tons per station. For example, we are paving 15.4 tons per station. Now let's take a look at the title sheet for a project. The title sheet provides general project information. This project is the Broadwater Southwest in District 5. You will find the project location, the project number, the traffic counts, and other project data, including the post-consumer recycle content in the lower left of the sheet. Here I have expanded the map portion of the title sheet. You can see the beginning and the end of the project. This project is from station 1015 plus 29 to station 1427 plus 81, for a total of 412.52 stations. It is easier to just change the plus to a decimal when performing math functions in stations. Another way to think of it, this project has 412.52 100-foot sections. A few pages into the plans, you will find the summary of quantity sheets. For this Tech Talk, we are going to focus on Group 9, bituminous. Let me expand this a bit so you can see it better. Within Group 9, we are going to focus on the main paving item, asphaltic concrete type SPR. For this project, there are 32,270 tons. After the title sheet, there are typical section sheets. It shows the cross-section of roadway, the legend to the right showing each operation. Below that is the beveled edge detail we are going to talk about next. And finally, in the lower left is a tonnage breakdown note. We will discuss this later in the Tech Talk. Here is an expanded view of the typical section. This typical section is the primary section for the entire project, with one small exception. There is a short section that has existing asphalt shoulders. The project paving primarily consists of milling the roadway 3 inches and then placing 4 inches of SPR shown in green. Circled in red is the beveled edge detail, which we will go over in the next slide. This is the beveled edge detail. It is a little busy with all of the measurements, but basically it is showing that the area highlighted in red will be removed by the milling machine, slightly inside of the edge of the 12-foot roadway, milling a new vertical face at the edge of the roadway and cutting a trench that is 1.5 feet wide. Then it is paved as shown in blue, adding this beveled edge feature shown in the darker blue. Here is one more detail on the typical section sheet I want to show you. It is the notched wedge. The notched wedge I have highlighted in blue. This is used on most projects, generally at the contractor's option. It is primarily used at the center line to help smooth out the drop-off between lanes. So here is the plan's typical section, and below it I have expanded it, so it's easier to discuss in some detail. This project is going to be paved with a 2-inch bottom lift and a 2-inch top lift, and adding the beveled edge on both sides as the typical detail shows. Now let's go over the paving operations that will take place during construction. The first bottom lift will be accomplished by paving 2 inches in depth. Also included during the paving would be the beveled edge on the right and the notch wedge at the center line. We will call this paving computation number 1. The 2-inch by 12-foot section we will call area A, the beveled edge we will call area B, and the notch wedge at the center line we will call area C. So now let's begin the computations. We need to calculate the end areas. Area A is 2 inches thick with a 12-foot wide lane. Convert the 2 inches to feet by dividing by 12, and we end up with 2.0 square foot. Area B is the beveled edge widening. For this, we could either scale and measure from the drawing or get the measurement from the CAD drawing. In this case, we got the measurement from the designer, and it was 0.2606 square feet. Area C is the notch wedge at the center line. For this, we could either scale and measure from the drawing or get the measurement from the CAD drawing. Again, in this case, we got the measurement from the designer, and it was 0.0571 square feet. Add all 3 of them up, and we get a 2.3177 square feet. Now we need to calculate the volume of material per station. We take the end area that we just calculated, the 2.3177 square feet, and multiply by 1 station, or more specifically, 100 feet. This gives us the volume of 231.77 cubic feet. Now we need to convert the volume to weight. This table is available on the NDOT website. The link is shown at the bottom of the slide. It is called a materials computation sheet. Here we need to find the unit weight of SPR per cubic feet, and it is showing that the SPR is 148 pounds per cubic foot. Now we need to convert the volume of tons of material. Take the volume, 231.77 cubic feet, and multiply by 148 pounds per cubic foot, and you get 34,302.96 pounds of SPR. Now divide it by 2,000 pounds to get the amount of material into tons. That comes to 17.15 tons in 100 feet of paving, or more commonly stated as 17.15 tons per station. We also need to add the slope and profile corrections that we will cover towards the end of the tech talk. Now let's look at paving the matching lane. We have the 2-inch bottom and the widening section and the notch wedge from the previous paving. We will call this paving computation number 2. Let's call the lane area, area A, the beveled edge widening, Area B, and the notched wedge paving, Area C. Again, Area A is 2 inches by 12 feet for a total of 2.0 square foot. Area B from the CAD drawing is 0.2606 square feet, and Area C from the CAD drawing is 0.0571. But this section must be subtracted since it was paved during the first lane of paving, so the total comes to 2.2035 square feet. So now we have the end area, and we multiply times 100 feet to get the volume. Convert the volume to tons by multiplying 220.35 cubic feet times 148, which equals 32,611.8 pounds. Now divide by 2,000 to get it into tons, and we have 16.31 tons in 100 feet of paving, or 16.31 tons per station. Again, we will discuss adding the S&P correction tonnage towards the end of the tech talk. Now let's look at paving the first lane of the top lift. We will pave the 2-inch thick lane and the widening section and the notched wedge all at the same time. We will call this paving computation number 3. Let's call the lane area, Area A, the beveled edge widening area, Area B, and the notched wedge paving, Area C. Again, you're getting this. Area A is the 2-inch by 12-foot lane that is 2.0 square feet. Area B from the CAD drawing, this time, is 0.0585 square feet. Area C is also from the CAD drawing. It is 0.0571 square feet. Sum them together and the end area is 2.1156 square feet. Now we have the end area of 2.1156 square feet times the 100 feet to give us 211.56 cubic feet. Multiply this times the unit weight of the SPR of 148 pounds per cubic foot, then divide by the 2,000 pounds to get it into tons. That equals 15.66 tons per station. And finally, we will do the same computation for paving area number 4. Again, we computate area A, B, and C. Remember that area C is subtracted this time because the notched wedge was already paved in the previous slide. Take the end area of 2.0014 square feet and multiply by 100 for the volume, and we get 200.14 cubic feet. Now multiply times the 148 pounds of unit weight and divide by 2,000 to convert into tons. We get 14.81 tons per station. Now we have computated all 4 of these sections. Let's take a look at the slope and profile tonnage corrections for section 1 and 2. The S&P tonnage is the tonnage allowance in the plans designated to be placed in the lowest lifts of the asphalt to account for slope, profile, and smoothness corrections. Again, this is to be placed in the lowest lift of paving on the project. So let's take a look at the project tonnage design for this project. Looking at the Group 9 item SPR, the planned quantity is 32,270 tons. Now let's look at another sheet in the plan set that is just past the typical sections sheet. It is called the General Information Sheet. On this sheet, it shows the super elevation correction for curves on the project and the super elevation rates. Let's expand the sheet to see it a little better. Here it is blown up a bit. You can see on the table at the right, it shows the super elevation tonnage and correction of 850 tons. On the table to the left, it shows what we are looking for. The slope and profile correction of 4,350 tons. This 4,350 tons is the tonnage that must be utilized in the lowest lift of paving and reflected in our tonnage rate calculations. Here is the typical sections again, and you will notice that for this project, this tonnage detail note was added. Let's expand this view and take a look at it in more detail. This is the new information only box that will be shown in all plan sets. You will start seeing them beginning in 2023 designed plans. This is a quick and handy breakdown of all the plan SPR tonnage. The S&P correction tonnage will be shown here, and it is 4,350 tons as we saw earlier. Now we know that we must include the 4,350 tons into the bottom lift tonnage rates. This will be utilized over the 412.52 stations of the project. So now let's take the 4,350 tons and divide it by the 412.52 stations, and we come up with the 10.55 tons per station S&P correction allowance for the project. This is for both lanes, so let's divide it by 2, and we get the correction for each lane that comes up to 5.27 tons per station. Now let's add the 5.27 tons per station to the bottom lifts, Comp 1 and Comp 2, and we get 22.42 tons per station and 21.58 tons per station respectively. Comp 3 and 4 do not change since it's only being utilized in the bottom lift. Now we will finish the presentation with some tech tips. Run slightly higher tonnage on the first lane paved of each lift. Compute tonnage rates at 200-ton increments or 1 hour of mainline type paving, whichever comes first. Thickness stabs are 125% of the compacted thickness. Compute tonnage rates to check the entire project, especially when the entire bottom lift is complete. Be safe and aware of your surroundings at all times. Tip number 1. When running the first lane of paving, you should bump your tonnage rate up slightly, approximately 0.5 tons per station, because when matching the other lane, it tends to run lower. So you would want to increase Comp 1 and Comp 3 by about 0.5 tons per station. Tip number 2. Compute tonnage rates at 200-ton increments or 1 hour of mainline type paving, whichever comes first. Computing on short sections leads to inaccurate rates. At the start of the day, make sure to wait, say 5 loads or so before you begin a rate check. This allows everything to equalize in the hopper and paver. As you can see in the diagram, you will need to make sure you perform the rate check at times when the load of the MTV is of similarity. And you will need to make sure which truck ticket is included and when to end the rate check per the truckload location. Let's take a look at that in more detail on the next slide. The tonnage check needs the tonnage and the station distance to perform the calculation. At location number 1, we would need the cumulative tonnage from the ticket and the station. At location number 2, we would also need the cumulative tonnage from the ticket and that stationing. For the tonnage, we would take the cumulative tonnage from location number 2 minus the cumulative tonnage from location number 1. For this example, let's just say it was 1,534 minus 1,215 tons to equal 319 tons. For the stationings, we subtract the beginning and end stationings. So let's just say 25 plus 33 minus 10 plus 08, or 25.33 minus 10.08. That equals 15.25 stations. Now just take 319 divided by 15.25, and you get 20.92 tons per station. That is the tonnage rate that is being ran in this example. That's it, you have completed a tonnage rate check. Tip number 3. When checking loose mix thickness, they use a narrow steel rod poker. In order to get the correct compacted thickness, the loose material needs to have an extra 1/4 inch per inch of compacted. So if you want 1 inch compacted, you will need 1 1/4 inch loose. 2 inches compacted, you will need 2.5 inches loose. 3 inches compacted, you will need 3 3/4 inch loose material, and so on. Tip number 4. Compute tonnage rates to check the entire project, especially when the entire bottom lift is complete. Calculate tonnage at several large milestones, such as halfway complete on each lift and when the bottom lift is complete. When the bottom lift is complete, it is most important because you can adjust the top lift rate to hit your planned quantity nearly exact. And the most important tip we saved for last: safety. Safety is everyone's business. Be aware of your surroundings and always watch out for each other. You are NDOT's most valuable asset. This sheet is what is entered during the laydown. It documents exactly where the inspector took the samples, according to the random sampling schedule. This worksheet does not replace the random sampling schedule. It just helps keep track of the daily laydown sample data and necessary checks, such as temperature, slope, and thickness. This is another summary sheet. It is generated from the laydown data. The laydown inspector and plant inspector should go over this with their contractor daily to make sure everyone agrees on the quantity. That way, at the end of the project, you agree on quantities. Again, this will save you a lot of time. Next, we will move into testing in the lab and how it is performed. You will see different videos for each testing method.
In this video, we will show the proper testing procedure for an asphalt sample. The sample has been brought to the proper temperature, verified by a thermometer. The sample is dumped out and then thoroughly mixed. The first test being shown here is for the gyratory compacted density with voids, or GMB. A sample of roughly 4,800 grams is collected and put into an easily pourable container. After the proper amount has been collected, a thermometer is put back into the sample and put back into the oven so it can reach the proper compaction temperature. After the compaction temperature is reached, the mold is taken out of the oven, a paper disc is put into the bottom, a funnel is then used to put the sample in one continuous motion. A spatula is used to level out the top of the sample. And then a top paper disc is placed in. Once the sample is properly into the mold, it is taken to the gyratory machine. The notch on the front of the mold will match up with the screw in the gyratory machine, and then the machine is started. The ram head comes down into the mold to compact at a certain height. Make sure the ram head is properly aligned. After the ram's head is all the way down, it will rotate the number of times depending on which type of asphalt material. After the compaction is over, a sheet will print out with your heights. The final height must be at 115 millimeters plus or minus 5 millimeters. The sample is then extruded . The paper discs are taken off as the sample is extruded. The sample is then placed in front of a fan to cool down and is labeled with the proper sample ID. For the density test, the sample is placed on top of the scale to get its initial dry weight. After the weight has been recorded, it is placed into a water bath that overflows. The water bath must be at a temperature of 77 plus or minus 1.8 Fahrenheit for 4 minutes plus or minus 1 minute. At this time, you will dampen a towel for the SSD. After the 4 minutes is up, record the weight in water. Then remove the sample and place on the dampened towel to absorb the excess moisture. Place the sample back on the scale for the surface saturated weight. The next series of tests is the burn-off and gradation FFA tests. First, you get your empty weight of the burn-off cage and then take it apart. After it is broken into 2 pieces, fill up the first half, roughly 800 grams of asphalt. After 800 grams are placed, spread out evenly. And then move the sides away from the walls roughly 1 inch. Place the top half of the cage back on. And repeat the same process of roughly 800 grams of asphalt. After the top half is finished, place the top and the clamp back together. Reset your scale and get the total weight. Now you can subtract the total weight from the empty basket weight to get your sample weight. Bring the sample to the ignition oven and enter your sample weight. Re-hit the weight button to make sure you have the correct weight of sample, and then zero the scale on the oven. Always make sure to wear proper protective equipment. Place the sample in the oven by putting it all the way to the back and then down onto it, not sliding across the bottom plate. Close the door and then wait for the scale to even out, making sure it's within 5 grams of the total basket and sample weight. Then you can start by hitting start. Make sure the door is locked and that the sample receipt is starting to print. After it is done, remove the receipt with the sample information. Hit the stop button to unlock the door. And then remove the sample. Place the sample on a stand. And put a warning over top of it to prevent anybody else from touching it because it is still very hot. After the sample cools, pull the basket apart to begin cleaning out the basket. Use brushes to completely clean out the baskets. Make sure to clean the bottom plate as well. Next is the washing of the sample. First, you must wet the sieves and the sample completely before adding a soap agent to the sample. After the soap has been added, mix thoroughly with the spatula. Then dump the sample over a set of sieves, either a 10 or a 16 sieve over a 200 sieve. Wash multiple times until there is no material floating in the water. Once there is no more material floating in the water, you can clean the sieves to put back into the sample. Rinse the sieve out with water over the sample so that it is all collected. Then place the sample into an oven at roughly 110 degrees Celsius. When the sample is dry, remove it from the oven to let it cool. Once the sample is cool, it is ready for gradation. First, clean the pan, put it into a scale to collect the initial weight. After the initial weight is collected, pour the sample into a series of sieves. Place the sieves into a shaker and shake for 10 minutes. After shaking, the sample is ready for its gradation. Remove the aggregate from the sieves back onto the scale and record the weight. The coarse aggregate angularity test uses material from the number 4 sieve up to the 3/4 sieve. Once the 3/4 sieve to the number 4 sieve's total weight has been collected, write the weight down and then pour out into a pan. Pour this aggregate out into a pan and check for any aggregate that has no fractured face. Fractured face is any rock with a sharp edge to it, so we're looking for any that have round edges.
Visual test.
After all of the round rocks have been picked out, place those back onto the scale and record the weight. The total weight subtracted with the round rock weight will give you your CAA. After the CAA is collected, you can finish the gradation, recording all of the weights. The FAA uses aggregate from the 8- sieve to the 16+ sieve. The -16 sieve to the +30 sieve, the -30 to the +50 sieve, and the -50 plus 100 sieve. To test the FAA, you must scoop out proper sample sizes from each of the collected material that we took earlier. 44 grams of plus 16 material, $57 grams of plus 30 material, $72 grams of plus 50 material, and 17 grams of plus 100 material. After the FAA is collected into a single pan, it is then mixed up After the aggregate is thoroughly mixed, place a finger underneath the bottom of the funnel, pour the material in with 4 to 6 seconds, level the top of the mound, then remove the finger from the funnel and pour into the brass cup. Strike off the top of the pile from the cup, tap a few times, sweep any remaining aggregate from the bottom of the cup, then record its weight. Repeat this procedure a second time to get an average of 2. The final test shown here is the Rice or voidless density test. First, collect a sample of roughly 1,700 grams. Place that sample in front of a fan to help cool it. Spread the material out to prevent clumping. After the sample has cooled enough to touch with your hands, break apart any clumps larger than 1/4 inch. Fill a water bath with 77 plus or minus 1.8 degree Fahrenheit water until it overflows with water. Verify the water's temperature. First weight you want to record is the empty weight of the container. Then fill the container with room temperature asphalt. Then record the weight of the bowl with the asphalt inside of it to get the sample weight. The next step is to fill that bowl with enough water to cover it with 1 inch above the top of the sample. Stir the sample with a spoon to prevent any air from getting trapped along the sides and the bottom. Place the container on top of the shaker. And then put the lid on top. Make sure to put water on the rubber O-ring to prevent it from snapping. Also make sure to wet the bleeder valve. Properly clamp the container and then start the rice machine. The vacuum pump will start and bring the internal pressure down to 27.5 millimeters of mercury. Once the machine reaches that pressure, it will run for 15 plus or minus 2 minutes. After the 15 minutes are up, the container is unlocked. Make sure any asphalt floating on the top of the water is pushed down into the sample. Transfer the container to the water bath. Once the container's in the water bath, let it run for 10 minutes. And then collect the weight in water. After the sample is removed from the container, return the empty container to the water bath to get the empty weight in water. Using those weights, we can calculate the density without air voids.
Let's talk about the testing and production tolerances. The contractor shall assume the responsibility to cease operations when the tests show that they are not meeting specifications, other than those on Table 1028.17, and shall not start production again without the approval of an engineer. Testing shall not show the correlation consistency in one direction, either high or low. Generally, this will fluctuate. Additional tests may be taken from the roadway for IA correlation checks by the QA manager or another sample from the lot. What happens when the testing tolerances aren't met? An IA review or independent assurance review is required. When an IA review is conducted, we will review the technician and the equipment for that particular test in which tolerances weren't met. The IA will be done by the QA manager or a representative. Equipment may need to be repaired or replaced, and the technician's procedure may need to be corrected before production can continue. A letter will come from the QA manager to the project manager, contractor, flexible pavements engineer, informing the contractor of what tolerances are out from our verification testing and of the upcoming IA. IAs may be necessary several times throughout a project's material production. One last area I want to cover is the SuperPave test reporting software. This is the first page, the introduction sheet that contains the project and the mix information. Each of these workbooks may have many pages, as you can see at the bottom under the spreadsheet tabs highlighted in red. The SuperPave software is used by the contractor to enter all lab test data. All of the project test results can be found in this one file, including the density testing. This is the lab summary spreadsheet that the NDOT laboratories utilize. Note the required specifications and testing tolerances at the bottom of this sheet. Before being uploaded onto OnBase, the heading is completed by the Lincoln Central Lab. Notice the rows are alternating white and blue. The white lines report NDOT verification test results. The blue lines report the contractor test results. This shows the correlation between the contractor and NDOT. The results need to meet mix type specifications, production tolerances, and correlation testing tolerances. This is the summary page. It shows the results of all the contractor testing. I'm not going to go over this entire sheet. Just notice that every test result for every property is reported on this sheet. This is where all of the data for the summary sheet in the previous slide comes from. This is where the contractor enters each test result for each individual sample. Every sample has its own worksheet like this. This data automatically populates back to the summary sheet. And finally, this is what the roadway density sheet looks like. There are locations for both core and gauge data to be entered, along with core locations and offsets. Now let's move into our last module, Module 7. In this section, we will cover a variety of miscellaneous topics, such as trench and blade widening, moisture issues, our latest roadway patching specs, installing bridge deck membranes for overlay, and finally, paving super elevated curves in Nebraska compared to the Atlanta Motor Speedway. Let's start with roadway widening. Trench and blade widening is typically used when a roadway is being widened anywhere from 1 to 4 feet. We will see it done by the use of motor grader and with a milling machine. Here is a series of videos on a project showing several different methods of this operation.
Motor grader is removing part of the material for the trench widening. Most of the projects require a milled trench widening, but this particular project required blade widening. So he's moving the excess dirt out of the way. After the outside pass with the broom, second motor grader comes along with a special shoe attachment on their blade to finish making the trench for the trench widening. He's got a blade that's extended onto his motor grader moldboard that dips down an extra 3 inches rather than the whole thing being straight across. You can see the deepened blade on the edge of the moldboard that cuts the trench for him. After the trench is cut, a final pass with the last roller across the entire pavement to clean it up and get it ready for the tack. After he's finished, he leaves a nice vertical edge along center line from yesterday's paving operation.
This is a photo from the end of one of the videos. I wanted to point out a couple of things. This shows the section of tack on the left that is mostly all broke, and on the right, tack that was just shot. This is still brownish in color and therefore not broke.
Trench widening with the milling machine and filling with HMA in the same operation. On this project, a milling machine is being used to widen the trench. It mills down to the specified depth and removes the loose material. After the miller passes through, a sweeper comes through and cleans off the roadway of any remaining material. Next, a tack coat is laid down over both the road and the widened trench. After the tack breaks, a load of asphalt is laid on the road and a blade pushes it into the trench. Finally, a roller compacts the asphalt.
Now let's shift gears and look at some scenarios where we may have some moisture issues. Here they are paving when a fast-forming cloudburst downpoured an inch of rain for about 15 minutes when the contractor was in the middle of their paving. This is a picture of the loose mat that got poured while paving. It saturated all the loose mat, and when they tried to compact it, it wrinkled, as you can see on the right side of the photo. The water steamed up from under the roller, and it completely ruined the mat. What can they do during the paving operation? Pump the brakes, that's for sure. The contractor stopped the paver and held the trucks that were tarped up until the storm passed. Here is a photo just after it stopped raining. You can see in this photo the fast-forming storm moving off, but leaving a mess. Here you can see the contractor's motor grader used to blade up the hot mat for removal of the freshly laid material. This is a picture of a different issue on a different project. The field personnel called and said that the tack was not working and that the new paving was sliding off the road. As you can see in the photo with the shovel, there is plenty of tack on the road. It turned out that the existing roadway underneath was weak and it was flexing under heavily loaded trucks. This produces so much movement that the tack bond eventually fails and the new overlay starts sliding. This all needs to be removed and replaced. This is on another project where the field personnel called and said they had some rutting of the new asphalt. This turned out to be a much bigger issue. It had subgrade and base problems. You will see in the next photo. This is further down the project, at the end of paving. Clearly there are subgrade issues that need to be addressed. In order to fix something like this, the contractor would need to remove all the unsuitable material and bring in good material to establish a good subgrade. Then it will be ready to be paved on. While the laydown here looks good, notice the water along the edge of the surfacing. This can lead to a much bigger problem. Always maintain positive drainage and don't pond water next to the roadway, or it will go under the pavement subgrade and start breaking up. See the block cracking in the wheel path next to the yellow painted center line? This road is going to need significant patching. We want to be sure the entire damaged portion of the roadway is removed before replacing with new asphalt. Here is a good segue. Let's go into the next section, patching. Next, we will discuss our current roadway patching specs. In this photo, the crew has marked out the area of the road that will need to be removed and prepped for patching. Section 516 in the Standard Specifications book describes our most current patching specifications. This specification states that patching shall be paid by the ton of asphalt when filling a patch up to 16 inches deep. Any additional depth over the 16 inches shall be paid by equipment rental and the amount of tons required to complete the work. For the large patch areas, it is common to use a milled machine to perform the removal. Here they are using a mill to remove existing asphalt. Next, you will see a video of a patch area on the shoulder.
After the shoulder patch is dug out and prepped, a back dump truck unloads its asphalt into the laydown machine. This laydown machine has a conveyor belt that shoots asphalt out the side into the patch. A blade connected to the laydown machine spreads the asphalt out to the correct height. A sweeper follows behind to keep the roadway clean. Finally, a roller passes through to compact the patch.
Now we will take a quick look at bridge deck waterproofing membranes. These systems get an asphalt overlay once they are completed, so let's get familiar with them. We will briefly cover the types, the surface prep, traffic, and paving. There are 3 types of waterproofing membranes: cold liquid applied membrane, roll applied membrane, and hot liquid applied membrane. The cold applied membrane is a high build elastomer spray-on system, uses a primer base coat and top coat with aggregate, and is applied at normal ambient temperatures. The roll applied membrane is a bituminous preformed roll system with a primer base, and it also is applied at normal ambient temperatures. The hot applied membrane is a high-build spray-on system, uses standard paving fabric, and is applied very hot at 300 degrees Fahrenheit. Here is a picture of the crew installing the cold liquid applied system. It is first primed, and then the base coat membrane is sprayed on. After the base coat, a top coat is added and covered with aggregate. Once it is complete, a tack coat may then be applied, and the bridge deck may be completed with asphalt. Now let's look at the roll applied membrane. Just as the name implies, it comes in sheet rolls, and they are rolled onto the deck after the primer coat is applied. It is laid with overlaps, and then it is rolled with compression rollers for adhesion. Then it can be tacked and overlaid with asphalt. Some of the roll types have plastic backing that must be removed while laying and unrolling the sheets, making sure to get the proper overlaps that the manufacturer requires. And lastly, we will take a look at the hot applied membrane. Here you can see the membrane is being applied with a spray wand. This is a 300-degree liquid, so keep your distance and safety in mind during application. It is then covered with a non-woven paving fabric. Next, you will see a video of the spraying application.
Gonna make 2 passes. The edges are all squared up. Make sure they overlap slightly. Plenty of oil. Very nice.
Here is the finished membrane with the non-woven fabric. Once the membrane has been placed, the bridge deck may be completed with asphalt. Now let's talk about the prep and cleaning of the deck before the membrane is installed. Generally, the decks must be cleaned to the extent that the prescribed cleaning can achieve. There are 2 types of cleaning that is specified. The first is abrasive blasting. It abrasively cleans down to a layer of fresh concrete surface, removing everything. The second type is power washing. It will remove any surface latencies. but it won't remove some stains on the deck, like binder and oil marks. In either case, all of the white curing compound residue must be removed. After installation, they have different requirements when it comes to traffic. Cold applied can have traffic. Roll applied should not have traffic unless absolutely necessary, and hot applied cannot have any traffic whatsoever. The requirements for paving only differ in tack, for the most part. For cold applied, heavy tack is needed. For roll applied, a very light tack coat is needed. And lastly, hot applied is not tacked at all. All three systems are best paved in 2 lifts, and the use of an MTV is recommended when applicable. Last but not least, paving super elevated curves in Nebraska versus the Atlanta Motor Speedway. As written in the standard specifications, rolling on the super elevated curves shall progress from the low side on each lane, maintaining the 6-inch from the edge requirement of the preceding paragraph. Roadways are super elevated on curves to help offset the side centripetal forces and allow the vehicle to take curves better and more comfortably. The maximum super elevation on most highways is 6 to 8%, which are much easier to pave than the Atlanta Motor Speedway, as you will see in the next slide. This slide is a picture of paving the Atlanta Motor Speedway. As you can see, they need to rig supports to keep the equipment up to the 28-degree banked curve. A 28-degree curve is a 53% slope, compared to regular roadways where the maximum slope is 8%. This type of paving requires some pretty tricky and innovative paving setups. Here is a photo of the raceway completed. Next is a video of the paving of the Atlanta Motor Speedway.
Atlanta Motor Speedway's old asphalt has been ripped up and the turns have been regraded. Now the track just needs to be topped with some fresh asphalt. Simple, right?
It is not simple, I promise you that. It looks easy, but it is not a simple process for sure. But it's what we do.
That's John Rauer of Sunmount Paving. Over the last 25 years, he's helped pave several racetracks across the country. Right now, his crew is working diligently to pave all around Atlanta's 1.54-mile oval, including its steep corners.
You're using equipment that is built for flat ground, and we're trying to stick it on 28 degrees. So again, there's a lot of physics, a lot of trial and error. There's some engineering to it, but mostly trial and error.
Atlanta Motor Speedway's new 28-degree banked corners have amplified many of those challenges, forcing some quick thinking and adjustments to keep the project moving forward.
We fabricate something almost every week to help us and come up with new ways to make it better, make it easier. For one example, the hook point on the paver, it totally didn't work.
We had to make some modifications to the equipment because it wasn't holding the paver up there. The paver wanted to keep coming down the slopes.
We moved it 9 inches, and that fixed it. So it's just a small 9 inches.
Thanks to speedy solutions like that, paving is well underway. All told, about 17,000 tons of material will be used to bring the all-new Atlanta Motor Speedway to life.
It's really satisfying to see asphalt going on the top groove. From here, things get easier naturally. Now we're worried about making sure everything's smooth, that the grades are right, that we're getting a good ride for the competition coming in March.
Playing a key role in making that happen is something that Rauer and his crew take pride in.
I always tell everybody when I get off one of these projects and I go to flat paving, it's kind of boring. The best days out here is the first day and the last day. And when you're done, and it's satisfying. You go home, you come back here and watch it. You watch it on TV, you know you took part in the process.
Especially considering the end result will be a spectacle unlike any other.
Well, that's the one thing we were trying to achieve that Marcus was really driven to us is we knew we had to repave Atlanta. How do we make it unique to the whole circuit? How do we make it its own racetrack not what was established as a cookie cutter mile and a half. Looking at what we've accomplished and what we've tried to do and what he sees us to do, we've definitely made it unique. So the fans need to see this because it's going to be something they've not seen on any racetrack. There's not another racetrack out there like it, so it's something that you got to see.
NASCAR takes on the all-new Atlanta Motor Speedway for the first time in 2022. Tickets for both race weekends in Atlanta are available now at atlantamotorspeedway.com.
This completes the NDOT Asphalt Field Technician 1 and 2 training. Please contact NDOT to submit your pretest and schedule your certification exam. Thank you.